Let's look at this problem. There is a speck of negligible mass that begins to fall under gravity and gathers water vapor at a constant rate, beta kilograms per second. We want to find the acceleration and mass after it has fallen 2.45 meters. Right? That's what the problem is all about. So here we have, let's say, there is a speck of dust which is practically zero mass, negligible mass, that starts to fall. When it starts to fall, it is gathering water vapor at a constant rate of beta kilograms per second. So what happens is, t seconds later, this was time t equal to 0, and t seconds later, let's say it acquired a velocity v, it had an acceleration a, and the mass was beta times t. Mass was beta times t. And the force acting on it was mg downwards. Now, what I can do is, this mg at this point, what would it do to the mass m? It will change its linear momentum. So this mg must be rate of change of linear momentum of the mass with time at this instant of time, right? This I could have written as v dm dt plus m dv dt. dv dt is the acceleration. Very clearly, dv dt is the acceleration. This is mg. M is beta times t, as you can see. So beta gt, and we have like a beta gt equals dm dt, which is beta, right? dm dt is the rate at which mass is accumulated, which is beta. So beta v plus m, which is beta t into a. Now, very clearly you can see that velocity versus acceleration are linearly related. You would expect acceleration to be constant, but nevertheless, let's figure it out. If I differentiate with respect to time again, then I get like a beta g equals beta dv dt, which is a, plus beta a is what I get, right? And that clearly gives me acceleration as g by 2. So the particle is falling with a constant acceleration of g by 2 meters per second square. Yes or no? So which means, after it has fallen 2.45 meters, how long it takes to fall 2.45 meters? So 2.45 starting from rest would be half of acceleration, which is g by 2. G by 2 is 9.8 by 2 into t squared. So that's going to give me, let's say, 9.8 equal to 9.8 into t squared, or I get t equal to 1. So, and in 1 second, what would be the mass? Mass would be beta t, beta into 1, that means beta kilograms in 1 second, right? So here's a situation where again, the mass changed with time, and we could obtain a useful result out of a problem, relevant problem. Thank you so much. Bye-bye.